My name's Luke and I'm here with Glenn, and we're in the Tindo Solar manufacturing factory in Adelaide, Australia. And Glenn's just going to give us a quick run through of how they produce solar panels here in the factory.
Yeah, thanks Luke. Let's have a look.
Let's have a look.
So what we have here is our laser cutter, and so we get a full-size cell. Goes into the machine. The blue light there is imaging every individual cell, looking for any defect or fault in that cell. So it's AI, and so if there is any fault, puts that to the side, we don't use it. So it's eliminating any faults from the very first stage. They're moved over there, and then we're laser cutting those in half. So we use a half cell cut technology in our modules. This gains greater efficiency from the module. Then we get those half cut cells, and they go into the stringer. So the stringer is where we're going to get start joining those cells together. So we have the wires come across here. We're getting those wires and cutting them to the right length. The cells come in like that. Underneath that robotic arm is imaging the cells as well. And so if there's any defective cells at that point, puts it in that tray and the front doesn't get used. The cell then gets preheated on the red lamp there, ready for soldering. Comes across here, we're interlacing the wires onto the cell. Heat on top of them, the wires are holding it inside to the right position. And then we're laser soldering with the over here. So we're creating these short stretches of 9 months coming down. So what we're doing here, we're picking up that string, we're actually closing the circuit over there and putting a current through that string. And then we're performing electromagnetic string. And then so there's the results there. It may mean there's some resistance in there. So what the software does is automatically put that string aside, but testing later by an operator. So only the perfect string here, like that. So only the perfect string can pass through, but everything else gets retested. We may cut out a cell, resolder and then retest. So we minimise waste and minimise any fault code. So the zero tolerance. So you see they're all picked up and maneuvered by suction, so it's all vacuum. So there's no stress on the cell, no hands, no picking it up. So then what we have here is a sheet of glass, solid glass, and the first layer of the encapsulant. And now we're laying up those 9 half-cut cell strings onto the glass there to create the format of the module.
There's one sheet of glass, isn't it?
Yeah, one sheet. So this is a 440 watt module we're making here.
Yeah. There's one sheet, one that sheet.
Yep. Yeah. And so we're laying it all up there. So what we got is all these independent short strings on the glass at the moment. We need to bring all that together to one circuit. And that's what the next machine does.
How thick is your glass?
3.2 mil.
3.2.
Yeah, tempered, low iron.
Some of the dual glass panels are less than that.
Yeah.
So dual glass is a great marketing thing, but sometimes when it's like a thinner, two thin sheets of glass, then it might not be as good.
Well, they break it down. They end up with 3.2 mil, but 1.6 on each side. Which sort of minimises protection of the cells on the front side in particular.
Well, that's why you need the protection on the front, to be honest.
So if we watch that come through now, what we'll see is all the cells get picked up, ready to solder on the bus bar there.
Yeah.
Right, so top, middle and bottom bus bar to close the circuit on all of those strings. So see it here. There you go. Now it'll probably, there it goes.
Soldered on there.
So it drops it on there, soldering now at those 3 points.
Solder on the front side. Yeah. Does it do like a resistance test or something for the solder? Another quality control.
Yeah.
Oh, here we go.
So now you can see they're
straight out of the oven.
All soldered together.
Yeah.
So now that's one circuit.
Yeah.
So between the stringer and here, on this size module, there's over 17,000 solder joints and they're done in 60 seconds.
That's so incredible. It's so smooth. Just go on.
See the next one coming through already.
Yeah, wow. How many, what, I don't know what metrics to track. What's your output like per day? Like how many panels are you making per day?
So we can make just over 1,000 modules a day over 3 shifts.
Okay.
We're not running 3 shifts at the moment. We are ramping up, getting forward, so as we're getting busier and busier all the time.
What's your capacity at the moment annually? How many megawatts?
About 180 megawatts.
180. Okay. I want to ask you about this gigawatt factory later, because I heard that might be on the cards.
Yeah.
Is that something you're looking at? Yeah, 1,000 a day. That's pretty good. Is that keeping up with the demands? Like,
at the moment, yeah.
Yeah.
But
We've got to ramp up. We'll need to increase
we're
the
continuing to ramp. So this month we'll make more modules than we've ever made in a month before. Next month it'll be more again, and so we're on this ramp process at the moment.
Yeah. Okay. So this month you'll make more modules than you've ever made before.
Yeah.
So
in a month.
Yeah. Tindo's really on the up.
Yeah. And next month forecast is for more again.
Yeah. Well, there's definitely a drive for people looking for more sustainable, ethical, renewable energy. Obviously, there's questions around things where it's coming from overseas. So obviously the demand for a local panel is building up, which is great.
If we look at last calendar year that just finished, we made double the modules we did the year before.
That's awesome. Yeah, I love that.
So what we do at this point is one of those points where I said we put in a manual process of quality control.
Yes.
We could automate this and not have this person standing here, but this is what
They still do a good job,
what Tindo's about. So we understand through our experience, the buzz bar is potentially a weak point in the module.
Yes.
1,000 volts passing through that for 30 years.
Yes.
So we routinely touch up certain points.
Yeah.
At this point, you can see there we're checking the cell gap, making sure it's aligned on the glass properly.
Yeah.
Nothing's moved. We put these little bits on that help with the adhesion during lamination as well. Excuse me. At this point also it gets a serial number. So from this point on it's a unique identifiable module, and it's scanned from this point on using that serial number.
That's good. We'll need that when claiming the rebates on the panels for the installation.
So it also means that if there is, if you get a module and in a rare occurrence there is a fault with it, whether it be immediately or 5 years' time, we can look at that serial number, track it back to who the operator was, what process, what materials we used, and identify what caused that problem.
Yeah, it's great. I mean, we do look panels from all different suppliers, and I've seen things like flies wedged in the glass between the cell and the glass, and I don't think this guy's going to let that through. No. He's pretty thorough check there. Yeah, no, I know your panel's got a really good quality control.
This machine here doesn't do a lot, and so all it does is it puts a little bit of tape between the cells there, and that stops the cells from moving during lamination, because the encapsulants, when they get heated up, they go to like a glue, and the cells can float and move. So it just maintains those cell gaps and holds them in the right place. So I call this Australia's most expensive sticky tape dispenser.
Yeah, okay.
Because that's all it does.
Yeah, wow. Oh, well, if it does the job, then it works.
Yep.
We'll say it doesn't work 24 hours a day. You need some humans here to monitor, don't you? Yeah. So we do two 8-hour shifts. Is it running this factory running 16 hours
We're doing a shift and a half at the moment. So two overlapping shifts, so about 12 hours a day.
Yeah, okay. What's the energy consumption like for the production?
It is energy hungry, but we've got about 230 kilowatt system on our roof here.
Yeah.
And so over the whole year, obviously summer, winter, that accounts for about 50% of our energy needs. Over summer, it accounts for the majority of our energy needs.
Yeah. Over summer. That would be good to me though. I have heard people say, particularly some of the factories in China can be big polluters. I've heard people say the Chinese government made a move out of the cities to get all the smog that was polluting the cities, push them further away. That's what you guys are pretty clean here. You don't have a problem with that.
So if you look at the energy mix in the South Australian grid, it's about 83% renewable at any point in time.
Yeah.
And you add in that we're 50% self-sufficient. So we have a very low carbon footprint on any module made. And so we've had a study commissioned, and we're about 75% less carbon per megawatt of modules compared to imported modules.
Yeah, wow, that's
So it's a
great.
huge difference,
So, yeah, it's good. Well, using solar to make solar panels makes sense.
And then there's
you don't want to
also-
be burning too much fuel while you're making these things.
100%. Then there's also the carbon miles as well, so the freight component. So because we're importing, yes, a lot of our materials are imported, they have to be, but they're small materials, it's very dense within the containers. So we get a lot of density of material as opposed to finished modules, far less dense. So there's a lot more carbon miles importing a finished module than there is in a Tindo module.
Yeah, okay. Yeah. So obviously we're still getting some of the raw materials and cells from overseas.
Yeah.
Yeah.
This
There's
pulls out.
I mean, obviously there's a lot going on here though. That this is definitely.
This pulls out the second layer of the encapsulant. So a lot of people, you would have heard it. You may even have thought it and said it to customers that Tindo don't manufacture modules, they're assembler. It's not until you come here and you fully appreciate, we've got a raw cell, we're soldering it, we're cutting it, we're soldering it together, we're making the strings, and then we're putting all this together, all these components, and then we've got to laminate it and glue it all together and then put spraying on. It's not assembly, it's a full manufacturing process.
Yeah,
and it's exactly the same as you said that happens in China. Is what we're doing here. So if a customer or a competitor wants to call Tindo an assembler, they're actually calling every Chinese manufacturer an assembler as well. We're all in the same boat.
This is exactly some of the factories I've been to in China, Michael and Trina. This is very, very similar. It's just actually a lot smaller.
That's right.
Not a bad thing. It's a bit more boutique, but I know you guys are growing as well.
That pulls out the back sheet. And so now we have all the layers here of a module. We do another QA inspection at this point. So if we look at this, we've got the glass, first layer of encapsulant, the cell, the second layer of encapsulant, and then the back sheet. That's all the layers.
Do you ever have issues with dust in the factory? Or anything?
No, so this is a low dust environment and special air conditioning to account for that.
Yeah, okay. Yeah. Oh, that's good.
Then we did the electroluminescence test over there on the short string. Now we're actually doing it on a whole module level. So the module comes through, and so we're checking for any resistance. It puts a current through it, and we're checking for any resistance in any string or any cell. So at this point, it's a zero tolerance to any defect. If it's perfect, it goes through ready for lamination. If there's any fault at all, it goes off this way, and that'll be checked. And the likelihood is we would cut out the affected cells, resolder in, and then retest. Again, minimising waste, but also ensuring 100% quality.
So we're testing for the power output of the whole
No, not at this point. This is just the electroluminescence, looking for any microcracking, any resistance to current within the strings or the cells.
Yeah. See, that's good that you go to that kind of detail, because microcracks sometimes, pardon the pun, it slips through the cracks and then ends up on someone's roof. And if they've just got a standard string system, they might have even one or two panels that has microcracks in it. And they still kind of work, and they won't know, but we pull down the output of the whole system if you've got one panel there that wasn't quite as good as the rest. If you don't have N-phase or solar edge, most people would never know.
And in extreme cases, a microcrack causes a hotspot. A hotspot can cause a fire. I've seen panels burnt through the back sheet, cause fires plenty of times.
I've seen a couple in my day, but I don't. Yeah, you don't want to scare anyone with that.
No,
but
that's a fact. If it's a low quality, full of microcracks, that's the worst thing that can happen.
And I find with that stuff, you don't know until 5 or 6 years later as well.
Oh, you don't know.
Yeah. So, the installer's not around anymore, but it's good we go really thorough checks before we send it out. And talking about microcracks, one of the things that kind of comes up is the transporting of solar panels and solar cells from China to Australia on ships and trucks and boats, and then in cars. At least like when you're manufacturing here, you minimise a lot of the transport. I assume there's risk that comes with that as well, where
100%.
you open pallets and then there's panels cracked already and stuff.
So 100%. So when cells come just as cells, they're packaged far better like that in foam and boxes and cartons within containers. And they're actually quite safe. We do open it up. Sometimes they're broken. Sometimes some idiot has stood on it or whatever during logistics. But that's where we remove the broken cells, but the AI in the laser cutter is taking all those aside. So we're eliminating those at the very first point before we even cut the cells.
It's good. The AI doesn't miss a beat.
Yeah.
Yeah.
But then when we have our finished modules, I'll show you when we get to the end how we protect our modules for logistics.
Yeah, yeah.
So this is the laminators ready to go through for the lamination.
You've got the red, green lights and everything. So yeah.
So you can feel the heat in here. So lamination is heat, vacuum and pressure.
Yeah.
Alright. So like a big office laminator, it's sucking out all the air, compressing it and then baking it in here for 20 minutes at 150 degrees C. They come out of there, they go through the cooling station we just walked past, cool the modules down, and then now we've got all those layers now glued and laminated together.
Yeah.
Right? And all we've got is this little overhang on the edge there.
It's just a, wow, just a little connection on the back.
Yep.
It's crazy, It's crazy those connections, how much power goes through them.
Yeah.
Yeah, it's got to be perfect.
So then this is the auto trimmer, trims off that little overhang with the laminate.
Yeah.
So that young lady that was just standing there looking at the laminates, she's our head of quality.
Okay.
So PhD in photovoltaics out of Adelaide Uni.
Yeah, right.
You know, if we weren't here
Smart people.
in Australia, to do what she's trained for, she'd have to be working overseas.
Yeah.
You know?
Okay. Which is one of the questions I wanted to ask you, and maybe we can go into this a bit more later after the tour. But how do you learn all this stuff? How do you get into all this stuff? Do people come in and help you set this up, or is this how does this work?
Yeah.
If someone else wanted to start up a business manufacturing solar panels in Australia, where would they start?
Well, the IP we've got here has been built up over a lot of years. So our head engineer's been here 11 or 12 years.
Yeah.
And he worked in a PV manufacturing plant in South Korea for Q-Cell, running that plant. So he's got actually over 20 years experience of manufacturing modules.
You've got good people around.
And then the two I see to him and others, they've been here over 10 years as well. So we've got a lot of longevity in the manufacturing side of the business here.
Yeah, you got to have a good team.
And a lot of knowledge and IP built up over those years.
Yeah.
So that's a visual inspection there post-lamination. So we're looking for any foreign matter that might have got caught in the lamination, like a fly, like I said earlier, hair, anything like that. But any movement in the cells during lamination, we're looking for that as well. Once it passes that point, it comes through here ready for framing.
Yeah.
So this is the framer here. You can see the robotic head moving left to right there. That's silicon injecting the frame. That's our frame there. It's Tindo's proprietary design. So that's silicon injecting into that recess there, and that's where the laminate gets pushed into. We've got the mechanical joins on the miters, so very strong. It's a 35mm frame, so very rigid. So people don't put enough importance on the frame. We see modules coming into the country, very thin frames, 17mm I've seen. And it's like a wobble board. Yeah. And every flex is causing micro cracking in those cells.
Yeah, there was a bit of a trend a couple of years ago where I think the Chinese wanted to go as thin as possible with the frames, and they were getting thinner and thinner and thinner, and then eventually we were just getting pallets of just smashed panels, and then we're just sending them back, and then I think they kind of decided that they've reached the threshold of how thin they could go. I think they tried to push the limits a little bit, but 35mm frame, definitely not a bad thing, you know. I mean, especially as the panels get bigger as well. Yeah, like the old diving board, as they say, up on the roof, and you know, we need to have something sturdy for installation. You know, obviously my background is in solar installation, so obviously we're looking at clamp zones and stuff to be. We want good clamp zones that are workable with different types of roofs, tin roofs, and you know, you got weird screw lines and stuff. So the frame is really important.
Yeah, and we agree. So we actually pay more for our frame, but believe it's worth every cent for the integrity of the module, the long-lasting, longevity, durability, performance.
It's good to get oceans and stuff, salt mist and stuff like that.
Yeah, salt mist tested, rated. We have all that certification as well.
Oh, that's awesome.
So the reason that overseas manufacturers want to go thinner is the thinner they are, the more they get in a container, lowers the logistics costs, lowers the price of the module. That's all about cost.
Make sure you get smashed panels at the other end and send them back. Yeah.
frame goes on there. Now we fit the junction boxes.
Really important part of the process. I mean, I'm not on the roof much anymore installing panels, to be honest. I'm running the business, but when I was doing the installs, there was a lot of times things you'd see, like I said, thin frames was an issue, panels smashed. I've seen flies in panels. I've also seen these junction boxes fall off as well.
Yeah.
There was a bad batch a couple of years ago that came through of one brand, I don't want to say who, but like all the junction boxes were like hanging off by the time they got there. And I think it was actually because they were thin framed. I think the thin frame, the junction boxes were rubbing up against the back of the next panel.
Yep.
So that's something that's really important because, you know, that connections to all the power is going through that one connection.
If that fails, the whole module's dead.
Which could be the whole string, which could be half your system, or, you know, in some cases, you know, 70% of the system might be on one string.
Yep.
So, yeah, really important to nail that one.
One of the points I'll make at this point, so a lot of the supply chain has to be from overseas because apart from us, there is no industry in Australia, so the supply chain sort of matured.
Yeah.
But what we're actively doing as we increase our volumes, we're actively trying to onshore supply chains and incentivise Australian companies to manufacture for us. Yeah. So, for example, the frame now, we've got a contract with Capral Australia, which is one of Australia's largest aluminium extruders, to provide frame for us. So we've onshored that, and also our junction boxes we buy from a company out of Melbourne.
Yeah, well, it's good. Well, I see the Australian government is really interested in trying to do what they can to bring some production back to Australia. With, I believe, the ARENA program and Solar Sunshot, that there's a bit of funding through. But yeah, it's good to see that they want to see this stuff produced here because we are really going to be dependent on it in the future. If we want to be an energy independent country, then we're going to need a lot of solar panels and batteries.
And we can't be reliant on an overseas source for every bit of material that goes into it.
Ideally not, you know, ideally you want to be as independent as you can.
So what we're going to do here now is pop the junction boxes. And so fill them with a special kind of silicon material and make it totally impervious to any moisture, anything in the future. So give it longevity.
Yeah. Yeah, really important part of the process.
Yep. Again, you know, if the junction box fails, whether it be moisture ingress or come loose like you described, then the whole panel's wasted.
Yeah, well, the product's got to be perfect. You know, at the end result, the customer is paying for a perfect panel, and if they don't get it, it's a warranty claim, really. So
yeah, and what we have here now is our curing line. And so we've got wet silicon in the frame and wet silicon in the junction boxes. So the panels sit there to cure, for those silicons to cure off before we start moving them around and handling them in the next phase. Now what you described to me before where the junction boxes would come off, that's because they're not waiting for the silicons to cure. It's how much can we get through in the shortest possible time. That's contradictory to quality outcomes.
Well, it's a sliding scale sometimes, you know, like how fast do you want it, how good do you want the quality, sometimes go a little bit slower to get it better, but like I said, I mean, I don't want to say anything bad about anyone, because some of the places, the factories I've seen in China, some of them were quite good, but they actually took us to the better ones. I haven't actually seen the bad ones. Maybe that would be interesting to go see one of the bad factories in China to see how they do it. I'd imagine there's a few
manufacturers.
Yeah. You just want to get the volume out there and ship them all around the world.
So one thing installers tell us all the time is, and particularly on commercial jobs where there might be a long string of 40, 50 meters, is how square it always is and dead straight. Where imported modules might be like this.
Well, if you're doing a long run, that's really important because they go out over the distance of 20 or 30 metres. If you're doing a commercial job, 100 kilowatt, you've got a big row. You need the panels to be straight, otherwise you're there adjusting it for ages. And they might look okay from a drone shot, but when you go up on the roof and you can see it. So,
and that's because, like I said, we let those silicons cure off on the frame. And so if you're then handling the module before those silicons have cured, that frame only has to move a millimetre and suddenly it's not square and you're getting that effect on the roof.
the train tracks, and then it just
Yeah.
starts veering off
Yeah.
to one side, and you're trying to move it back to go the other way, and it looks like crap. Having nightmares of installs. Actually, I've seen actually another brand give out a really bad batch of panels.
Yeah.
They were supposed to be premium, and I guess they were good panels, but they were totally uneven and an absolute nightmare to work with.
Yeah.
It's not really acceptable.
So we do all our own R&D here. So every module that we release, it's all been R&D and developed here with our engineers in-house. And so this is sort of the R&D part of it, where we've got a flash tester there, we've got an electroluminescence machine there, which aren't on part of the line, so we can do testing offline and not slow down the production. Right? So if we look at some of these around here, there's an all black module, black buzz bar you can see as well in there. So we've been, that's now part of our release, so that was all R&D here. We're testing.
Another 475.
Yeah, that would be. We're testing, different materials from different suppliers, make the modules, test it, see what results we get. And that's part of our bill of material selection for our next release of modules.
Where's your final testing? So it's
around here. We walk past it and we go back. Yeah.
Sorry.
So the modules come off of the curing line.
Yeah.
They come down here. They get the nameplate label. So we're labelling this as a 440.
Yeah.
We get the covers on the junction boxes.
Yeah.
Serial number gets fitted to the outside of the frame as well.
So what are the final tests, like a power output?
So this is a flash test. So this machine, called the flasher, emulates pure daylight.
Yep.
So it flashes 1,000 watts per square metre of light onto the face of the module, and we have the leads connected to it, and so then we're recording the electrical output of that module.
Yeah.
So as I said, we're making a 440.
Final
So we have a positive tolerance only. Has to flash over 440 for it to pass here. If it flashes 440 or under, it's a fail, and we don't sell that module.
So your standard is to have a positive 0 to 5% tolerance, correct? And I know it's a thing within the industry is some of the panels will accept a negative tolerance. Some of the others, I think anything up to like minus 5%. Yeah. So you're getting a 440, but you're buying a 440, but you might be getting a you could be getting anything as low as a 420.
Yeah.
Yeah. So there we go.
That's the flash. See what that one is, a 444.24.
There you go. That's a 440. You could get that panel and it's 442.
Yeah, well, it's 444 that one.
Oh, sorry, 444.
And that's pretty typical of what we'd be flashing.
Yeah. Okay.
And so what we say,
really good
with Tindo, you're getting value for money. You're getting what you pay for and a little bit more because it's positive tolerance only.
Yeah.
And that's we rarely see a fail at this point, and that's because of all the QA we've done beforehand, eliminating along the way any material or anything that might create a longer term failure gets taken offline and we don't use.
With your total quality control or your warranties, callbacks, or whatever it is it 1 in 200,000 panels? Is that right?
Yeah.
Which is like, this industry standard is a lot less than that.
Yeah, so we had Dr. Andrew Thompson from ANU do some research for us a little while ago, and he said the industry average was 1 in 1,000 per annum fail. Tindo's was 1 in 200,000. And so he concluded 200 times more reliable than the average industry average.
Yeah.
And that, again, it's that zero tolerance to any defect. We just don't allow for it.
Yeah, that's so crazy. That's so crazy that you could be that much better.
And that's, so on the back of that, that's our, you'd be familiar perhaps with our $1,000 warranty offer. So if a consumer gets a panel that fails on their roof, we'll not only honour the warranty and replace the module at no cost, we'll give them $1,000 cash.
So 1 in 200,000 chance of maybe less. So they've got 20 or 30 panels on the roof. But still it's...
So we're putting our money where our mouth is.
That's amazing. Cool. So
the other thing we don't do here is binning, a binning process that you'd see in overseas manufacturing. Where it comes through, it gets flashed here, so they might be making a 440 as well, but it might flash at 420, and that'll get binned as a 420 module. or a 430 or a 410, or it might be making 485s and it gets binned as a 450. Right? And gets
So
labelled as such.
that's why the suppliers come to me and say, oh, hey, we've got some 420 modules cheap, do you want to buy them? That's what happens.
So
like, why did you make them?
What you're actually buying there is potentially a 440 with some sort of failure point in it.
Wow.
That they might know, they probably don't know, probably don't care.
Yeah.
You're buying a failed 440 brand new, putting on your customer's roof, and they don't know any better, you don't know any better, they're actually buying a failed module.
Wow, that's the panel that didn't make the cut and then they sell it off.
It's like a B grade.
Yeah, wow, yeah. You do see a bit of that with suppliers. Like I said, I do get them reaching out to me of weird panel, wattage numbers, and I can't fathom why they would make that number. Like why, like the 420s and the 410s and stuff. I'm like, why wouldn't you just make a 440 or a 475? Something that people want. But yeah, okay. That's get what you pay for, I guess.
Yep. You do.
Yeah.
So the next step after we flashed it comes to here. We'll have to wait for the next one to come through, but edge grinding. So we're filing off the sharp edge on the miter. We're then touching it up with the paint. And then passing it through here for the final visual inspection. The other thing that we do here, and I talked about it earlier, was what we do to protect the modules for logistics. So on each corner goes a corner block. Again, our proprietary design, recycled plastic, manufactured here. On each corner, so the panels stack on top of each other. No two panels will touch each other, and then they're locked in as well. I'll show you out in the warehouse.
Yeah. I was having a play with that in my warehouse yesterday. We had a pallet.
You just can't move them.
Yeah, it's because some of them they just ram them together. Maybe a little bit of cardboard in between the panels, and that's it.
And you cut the strap and they all fall out.
That's how you know a premium panel when they come with those.
Well, there's no point making a panel that's perfect with no fault in it, no microcracking, and then you ship it around the world or the country, and it gets to you, and now it's got problems because of that.
Well, yeah, and then even it comes to an installer and it sits in their warehouse for a couple of weeks, then it goes in the back of the van, and it's easier.
Jumps around.
If we can we're transporting it from our warehouse to the site, and we put it on the back of the truck. If we can just gently forklift the pallet back in without disturbing it, like the least disruption possible, because some people can't fit a full pallet in their truck or their van, so they'll just rip everyone out and then just throw them in the back of the van, and the panels are all scratched up and stuff by the time they even get on the roof. So something you need to be careful of.
And we take so much care in making sure every module's perfect. We want it to get to you perfect.
Yeah, you want to give it the best chance at life. Yeah. Even that, I was just touching up the.
Yeah, from where we filed off the sharp edge on the miter.
Oh yeah, there you go. So it's real attention to detail.
Yep.
Yeah.
So as I said, then it comes down here, robot will pick it up, and final visual inspection before it gets palletised. So I mentioned that the whole line was brand new. This is the only robot, the only piece of equipment we reutilise from the old factory.
I love these robots. So, can you tell me how expensive that is?
No, I couldn't. I don't know, to be honest.
You don't know?
No.
I've seen some of the ones we went to the Fronius factory, and some of the robots there, they're like, oh, that's 150 grand, that's 200 grand. Like,
they're not cheap.
I went to the Tesla Gigafactory in Shanghai.
Oh yeah.
Oh my god, that was on another level. The robotics they've got there, is just pulling up the cars, coming in, welding, coding everything, boom, boom, boom.
Yeah.
It's like absolutely insane.
Were they making cars or batteries there?
We went to, it was the model, well they're making Model Ys, and then we went to their Gigafactory where they make their megawatt batteries.
Oh yeah.
Not the Powerwalls, the bigger ones.
Yeah, waiting for the operator here to inspect.
Oh,
So it won't get passed until he inspects it and hits the button to pass it through.
The AI and the robotics is just crazy. It blows my mind. Makes it feel a bit like you're going to get replaced one day.
Probably all right. Then we're going to the warehouse here.
Yeah. got?
That's a lot of panels.
Nice and clean out here as well.
Yep. So from here, we distribute to our distributors.
Yep.
So AC Solar, Green
Yep.
Tech, Juice, and there's one more. Can't think of it. I'll think of it in a minute. And also export from here as well. So we've got over 20,000 modules in Vietnam.
Yeah, okay.
And looking at opening up other export markets as well this year.
So where do you export to other than Australia? Is it just Vietnam? Or?
Yeah, at this stage, yeah.
Yeah. I'm looking to grow that.
Yep, definitely.
I'm told the Philippines love Australian solar panels. That's what I heard.
Okay.
Yeah, when I was over in the Philippines last time doing some business there, we've got a few of our staff there. They said, oh, they love Australian stuff. Get Australian stuff over there.
Okay.
They asked me to get it over.
All right. Well, you can sell it over there.
Yeah, I'll ask if they'll ask him. Yeah.
And as I said, with these corner blocks on, that just doesn't move.
Yeah.
So we're 100% confident. It's just been flash tested. We know what the power of all these modules are. But with that, when it gets to your warehouse, it's exactly the same.
Yeah. It's flawless.
So that's how you make the best solar panel available in Australia.
There you go. That's awesome. Thanks for the tour.
You're welcome.
Now, we just finished up the factory tour. Really impressive. So I want to go over, we'll just break down some of the things we saw then. But before we go into too much detail onto the factory tour and the production, do you want to just give me a rundown of the history of Tindo and the story, when it started and when you got involved?
Yeah, so Tindo was founded in 2011 by, the main partner was Adrian Ferretto, who came out of Solar Shop. And he's a mechanical engineer by trade and so has a passion there for robotics and manufacturing, and really wanted to prove that high quality solar modules can be manufactured in Australia still. And so he set up the original plant, which is just next door to this one here, and much smaller plant. A lot of sleepless nights, he tells me, and but got it off the ground. And he was known for high quality and durability and longevity of modules, and had a focus on quality. And I had another solar business in Adelaide as a competitor, and tendered for work with the state government in 2016 and to do solar on public housing. I was successful in that tender. The launch of that program with the Premier at the time was at the Tindo factory, so I was pretty confident they wanted to use locally manufactured modules. So I got in touch with Tindo at the time and formed a relationship with Adrian and Tindo, and then through that, less than 12 months later, I'd bought the business from him.
Yeah, wow.
It was 2017, yeah.
Was there original funding to get the business off the ground, or was that?
No, Adrian used all his own money. So he'd sold his share out of Solar Shop and put all his own capital into it, so to his credit, yeah.
It's really hard to grow a business from scratch, particularly manufacturing. I imagine there's a lot of outlay, so you'd have to be pretty confident. But obviously, he's done really well, and then you've come in
since I've purchased the business. So it was 2017. We ramped up production next door. Got to a point that was just too small for us. Bought this block of land here that we're on now. Built this facility in 2020, 2021. So purpose built for a brand new manufacturing line, and here we are now. We increased the capacity from the old line from 60 megawatt to 180 megawatt here, so we tripled the size per annum is the capacity, and we're ramping up production to get to that as soon as possible.
And that's getting supplied right around Australia at the moment?
Yeah, so we ship our product all over the country. We're in distribution channels around the country, and even some export overseas as well, predominantly to Vietnam.
Yeah, wow, I think Asia is going to be a good market for that. So, yeah, it'll be interesting to see if we can get some, Australian-made panels into Asia. Because, like I said, I was over there recently, and they were asking me about it. They said they love Aussie stuff.
Yeah, we'd love to. Like I said, we're already in part of Asia in Vietnam, and that's on the back of quality and longevity. It's a pretty harsh climate for solar modules there. Very humid, and solar generally doesn't like humidity.
Well, yeah, but even Adelaide, like I grew up in Adelaide, and Adelaide is definitely a harsh climate, I would say as well.
Well, in Australia, the country's so big. We go from Adelaide, where it's very arid and extreme temperatures. Just this Saturday coming, I think the forecast is 42. So that hot climate, and then you go up the east coast and you get into the humid areas, and then northern Australia, cyclonic areas, and so we have that wide varied climate and climatic conditions here, and part of what we do here at Tindo is engineer and manufacture our panels to suit that wide variety of climate and climatic conditions.
So is your production line always kind of expanding and evolving? You're adding new things in, upgrading new modules or panels coming in? Is this like an ongoing process?
Yeah, definitely. So we will release a model of a module, and at the same time we'll recommence, R&D for the next release. So it's about an 18-month process for us to R&D, manufacture, test, send away for certification, and that's under a 6-month testing regime with TUV, and then come back, have all the certificates, and then release to market.
Just the bureaucracy side of things is what, 6 months or so?
6 months of testing overseas, and then we've got to come back and put all of that testing data to the CEC and get that certified here for use in Australia as well.
Well, I guess everyone else that brings panels into Australia go through the same testing process, so I guess there's fair ground there, but it would be nice to see things streamlined a little bit there. If you guys can, get your R&D and your manufacturing up, and then it is always annoying for us as an installer when we've got, we know there's products coming and sometimes they're finished and they're sitting in the warehouse, so it's like batteries is a story, we get that a lot. And, waiting for CEC approval, and there's all this good stock sitting there and we can't even install it. It's not really helping anyone.
No.
But yeah, it's good. So we went through the whole production line, and you showed me all of your quality control checks and everything. So how many checks do you have throughout the whole process?
I think there's 27 points of QA throughout the line. So it's quite a number. And we have created this zero defect policy and mentality. And so we don't allow anything to pass through the line that has a defect on it, and we'll pick it up at one of those many points along the way, take that product off, keep going with the rest. And so when we get to the very last checkpoint, which is the flash test, the power class, virtually zero failure at that point.
It was quite a few, like you said 27, I definitely saw quite a few which were linked with AI as well that was going through and checking all of the cells to see if anything even looked like, it was a bit like I was looking at like x-rays or MRIs or something where you kind of try and tell, when a doctor goes, oh yeah, that's where it's.
So we do multiple electroluminescence tests on the full cell, the half cell, and then the module level and the short strings, and they still eliminate any of resistance to current, microcracking, anything that could cause a problem with either the output or the durability or duration of that module. Yeah, so it's very, very detailed that you go through. And what's your failure rate currently of panels that go out on roofs? So we had Dr. Andrew Thompson from ANU do some research for us a little while ago. And he researched that the average failure rate of modules around the world was 1 in 1,000 per annum. His research on Tindo was 1 in 200,000 per annum.
How did he get to that number? Was that?
Well, we looked at the amount of modules that we had manufactured at that point in time, amount out in market, and then how many warranty claims and failures that we'd had.
Yeah, wow, it's impressive. So tell me about the supply chain then, because obviously not everything is manufactured here. Like there are quite a lot of your panels is manufactured here, and we've seen that, but then some raw materials and cells are coming from overseas. So with the supply chain obviously coming from different countries around Asia, there's some people have considerations about that, like ethical industries there and modern slavery, or like as I've researched in China, they call it poverty alleviation programs, which I love. It's like 1984. But what are you doing there, like to mitigate that? Are you're not involved in that? How's your supply chain look?
Yeah, good. So firstly, I'd say anyone in the PV module industry that says we can give you 100% guarantee that we're modern slavery free potentially isn't telling the full truth. We don't believe that's possible to have a 100% guarantee. You'll get a letter from a manufacturer with a nice big rubber stamp on it and signed by somebody that says that, but we don't believe that's possible. But what we do is take every step we can to mitigate that risk. So we visit the factories, we have a audit process in place, a third-party auditor that does a full audit, which then highlights any risk areas. We then ask questions, we get responses in writing from the manufacturers, and so it goes through a whole process, and every supplier of ours has to go through that process every year. Yep. And then depending on the results from that, we then determine what the risk is, and we make decisions from that data.
Yeah, so would I be correct in saying that the silicon's mined and the silicon's processed and then that's sent off to another factory that manufactures the cells, and then in many cases you purchase the cells in bulk and bring them down? Okay, so we minimise a lot of that, yeah. And you were telling me on the tour that you've had people partnerships with people overseas that you've then cancelled for various reasons.
Yeah. So we've had examples of during that that mitigation process and the audit process, we believed that the risk was too high, and we've changed suppliers on the back of that.
Yeah. No, that's good to know. So what about you? The cells cover, we're doing a lot of the testing and the cutting and everything and all the electrical connections, and then one of the later things, there's two things, the junction boxes and then the frames. I mean, I'm interested in the frames. Are you locally sourcing the aluminium? Is that?
Yeah, so we've got a contract with Capral Australia, so based out of Queensland, one of Australia's largest aluminium extruders and suppliers. And so we're actively trying to onshore supply chains. We're the only PV panel manufacturer in the country, and so there's no supply chain in Australia for it. But we're actively, as we're growing and increasing our volumes, we're attracting manufacturers in Australia to be interested to supply to us, and we think that's a really important part of what we do, and for sovereign capability for Australia moving forward in the future, so we can be self-sufficient.
Geopolitical issues are on the news every day, and everyone, I think, wants to be a bit more independent. We have been getting notifications from our suppliers that prices of things are going up soon due to some changes in the tax system in China. I think it may not be correct, is that the VAT rebate, they pay VAT tax and they get a rebate back, and now that's getting reduced by the CCP, so now the cost of things coming from China is going to go up. We're expecting, I've been told anything 30 to 40% increase in panel prices in the next few months. Yeah. Does this affect Tindo at all? What are you forecasting in the next few months? Are you expecting?
Yeah, we've been notified by some of material suppliers of the same, so increase in costs coming and around that 30% mark. So our material costs will go up. Our labour cost, our every other cost won't change, and so what you'll see is the gap between an entry-level Chinese module coming into the country and Tindo, you'll see that gap closing in percentage terms. So we'll actually be closer to the imported module price.
The Chinese price will go up more than Tindo, so...
Yeah, in percentage terms, yep.
That's what I was hoping. That's what I was hoping you would say, but I wanted to confirm with you because, that is one of the considerations. Obviously, we sell a few different solar panels, but Tindo is more expensive than some of the other panels, but it's obviously more of a premium panel. Just touching on that, what do you think would be the key justifications for, like, if you had two quotes and, one was, a typical Chinese panel and one was Tindo, and it was, $1,000, $2,000 more to get Tindo, why do you think someone should go for the more expensive one?
Well, if you look at...
Tindo, at least the better one.
There's obviously multiple reasons, but if we look at, the key facts, data suggests that Tindo is actually the lowest cost of energy over time. So it's proven to be more reliable, more energy, lower failure rates, etc. So over the life of the system. If you think about solar is an investment over time. It's not something you get your money back day one.
I always say any investment comes with risk.
Yeah, 100%.
So you want to minimise the risk. You need to protect the downside as well.
Yeah, that's right. And we've got multiple points of validation of that. You look at the recent, Choice, the most recent Choice magazine test results. So Choice tested randomly 54 modules out of the wholesale market. They just sourced them from distributors. Tested 54 modules, and they ranked Tindo as the #1 module they tested. And Tindo was actually the only module they tested that met power class. Every other module actually flashed under its label.
Which is something you showed me with the flash testing in the factory before, is that every module that you flash test tests over the rated wattage. So we stood there, and right in front of me, we tested, the machine tested a 440, and it came up 444, right? 444.2.
Yes.
Which is, so every Tindo panel is flash testing over, and a lot of the other brands are actually flash testing under. So if you're going for a cheaper brand, you might be buying a 440, but it's only producing 420.
Potentially,
at a flash test, which may be less than that even on the roof.
Yeah, so we have a positive tolerance. We will not, if a panel flashes under its label, which is unusual, but if it did, we would not sell that. That's part of our quality control and part of our policy internal.
So tell me about the expansion. I know there was a government program last year, Solar Sunshot, administered by ARENA. They're doing what governments do, which is that they give out money to certain things that they want to fund, which is renewable energy, which is great. So you guys put your hand up for that. What did you get out of that, and what's the plans?
Yeah, so it was a long process with ARENA. It was over 12 months to pull it all together and get a final approval, but we were fortunate to be granted funding last year to the tune of about round figures $35 million, and that's to grow our own plant here, to increase the volume and scale, which and then also part of the large majority of the funding is a production credit. So that allows us to be subsidised, if you like, for making modules here to make us more competitive with imported product in the market. To help us scale. So it's a catch-22.
So part of it is to reduce the cost of what you're producing now.
Yeah. To help us to scale to larger volumes and then be self-sufficient at those scales.
Yeah, so I was just thinking, because I know it's a few years ago now in America. I think it was Joe Biden. He brought in, what's the word? The Inflation Reduction Act. I believe that's and I think Enphase got in on that, reduce the cost of their microinverters.
Similar concept.
Yeah, so a similar thing. So that it's partly the money is partly to increase your production, but partly actually to reduce the cost, so we can get it more affordable. So as the product's more affordable, we can get it out there more.
That's right. So as our cost to market drops, we're going to sell more and manufacture more. So it's growing our business to then get to scale, naturally. But then the funding can fall away over time, and we maintain that scale and those cost advantages at that scale.
Yeah. That's really interesting. And what's this? I'm hearing about a gigafactory.
Yeah.
Is this going to happen, or where are we at with the gigafactory?
So at the moment we have 180 megawatt capacity. So we've always had ambition for a gigawatt scale, which is 6 to 7 times what we're doing now. And the government, really wants to, have an industry here in Australia. And so part of the ARENA funding is also to help us proof of concept scale where we are now, and then do a feasibility study on a gigawatt scale factory.
Yeah, wow, that would be good. So obviously you're already the only of your kind in Australia. So then, if we can go ahead with that, then we could really take over the Australian market with Australian solar panels. Like you don't have any competition, right?
Not right now, no.
No, not right now. So that's good.
No, and if you think about it from sovereign capacity or capability perspective, and what's good for the country, we're employing people here, we're onboarding or bringing back supply chain to Australia, so that's creating jobs at other manufacturing facilities in the country. We pay tax here, so it's the money stays in the country here.
So a lot of big companies don't pay tax in Australia, right?
Yeah. Unfortunately, we do.
Tindo does. Yeah. Not funneling money through the Caribbean.
No. And, that's our social responsibility. We're getting, money from the government to grow the business and employ people, and we pay taxes accordingly.
Oh, I mean, it's the whole kind of circle of life, and at the moment we give solar panels out to homeowners, and we reduce the cost for them. So they provide business to us, we reduce their energy bills, and it's doing the right thing for the environment at the same time. So it's really a win-win for everyone. Yeah. The last thing I just wanted to go over while I'm here is the panels that you've got at the moment. So what's the current range that's available? And
so we're doing manufacturing right now Wellara 440 white backsheet, and then we've got a 475 black backsheet module in the Wellara series as well.
Yeah, that's good.
So they're the two that we are manufacturing now. We can manufacture modules up to getting close to that 600 watt utility scale as well. But that's we run that as a made to order.
Made to order? How long would that take?
Oh, it takes half a day to flip the factory over, and we can start manufacturing that the same day as long as we've got the materials here. So there's lead times involved, of course, but they're generally larger utility scale ground mount type projects that we get plenty of notice on.
What size project would that be?
Anything from we would say a couple of megawatt as a minimum to make it worthwhile to change over and get the materials in.
Yeah.
And then anything up from there.
That's interesting. I'm just thinking if there's any commercial projects that are coming up, we get our own custom-made Tindo order.
You could.
Yeah.
We've been fortunate enough to be awarded for a project in Queensland, Bowen Pipeline project. That's a 30 megawatt ground mount, and we will be supplying Tindo modules into that.
Yeah, wow. No, it's good. Well, it's all happening here. Is there anything else going on that we haven't discussed, or?
Oh, there's always something going on, and particularly in this industry. I've been in it for a while now, and nothing ever stays the same for too long. Battery subsidies have really put a shot in the arm of the industry, and everyone's crazy busy. And our module sales are going crazy. We last calendar year made twice as many modules as we did the year before. We're making more modules this calendar year than we've ever made before. Everything's ramping up and getting busier and busier.
Yeah, no, that's awesome. That's good to hear. Well, thanks for taking us for the tour. Excited to get some more of these out on the roofs. We've been working with it a bit now, and starting to ramp up more, especially as there's more interest in ethical panels, local made panels. So it's good. All right, we'll leave it at that. But thanks for having me.
No worries.
No worries. Thanks.
Thank you.